we will look at what we call it as the scientific method. Now, at any point of time, we can say that the humankind or the culture or various cultures have accumulated certain, so to say, truths and facts. So that forms a knowledge pool. And when we say certain truths and facts are clubbed together in knowledge pool, they are all validated and accepted as validated. And we call that as the contemporary knowledge that the culture has got. Now, technically speaking, we should not only include truths and facts in the knowledge base or a knowledge pool. I will not use the term knowledge base because it is overlaid, I mean, it is overworked in computer science. I will use knowledge pool. Uh, so, apart from truths and facts, we should also include morals and norms. Okay? Though their genre is different, okay, the whole world works and changes based on the truths and facts and morals and norms possessed by the agents and the decisions they take to address certain questions. So we cannot only look at truths and facts as the knowledge pool, we should also include morals and norms in the knowledge pool. But for the time being, for this particular presentation, we will consider only truths and facts. The I will reiterate the difference between truth and fact. A truth is a formal entity. Formal entity means it is about something which we call it as the theorems in mathematics. Okay. Like for example, any number, any composite number can be represented by multiplication of right numbers. Okay, so this is a truth. So while fact is an empirical entity and fact relates to physical world and the relationships and properties of objects which exist in the physical world. We call them as facts, and truths refer to the formal world. When we talk about truths and facts, okay, individual truths and facts, there are many, but many of them can be derived from a set of truths and facts, which we call it as axioms for truths and premises for facts. Now, the axioms and premises are the members of the knowledge pool and form the contemporary knowledge of that particular culture. Now, these axioms and premises come from two sources. One we call it as a priori truths. Okay, for example, uh, a priori truths is a term which is coined by essentially what we call as the philosopher Kant. Okay, and those are the truths in mathematics, okay, which intuition gives us a direct feel for that. Okay. We call them as a priori truths, and in case of premises, the premises are accepted facts, accepted in several ways, either as assumptions or as what we call as proven facts or validated facts and added to the knowledge. By using them, we normally form what we call it as a model. We can form different kinds of models. Now, for example, we can form a model in mathematics, say, for example, to test Goldbach conjecture, which says every rational even number can be represented by sum of two odd primes. Okay? That forms a hypothesis. Okay? And this hypothesis is to be proven, validated, or proven. Similarly, there could be a hypothesis whose genre is from real world. We call them as new premises or new premise type of hypothesis or empirical hypothesis which are to be validated. Now, by using the existing knowledge pool and the new actions of the new premises, we create a model to test it. So that we call it as model under test. Okay. This model under test is then solved or simulated. We use the term simulation here because some of the models cannot have what we call it as a closed form solutions, and they have to be solved by using a numerical method and so on and so forth, either computer simulation or numerical methods if it is easier to do that. So what simulation gives us is something, a testable result. Now, on the left hand side here, I'm showing what we call it as a formal validation. Formal validation is for essentially for those verities, okay, which are to be tested from the formal point of view. And there is a semantic validation which corresponds to validating a fact in the real world. So these are the two kinds of validations that need to be carried out. Now, right from the simulation, we get truth slash fact inferences. So these are the inferences which have to be validated. Okay. Now, the if it is a truth path which is to be done by using the formal validation mechanisms, like say for example proofs, like inductive proofs, a direct proof, and so on and so forth. There are several kinds of proofs which you can do. And what we have to do is that the truth inference which has been drawn is to be checked for what we call it as a logical consistency. Logical consistency is a very simple concept that when we have added something like a new axiom and we have found out the consequences of that by creating new inferences, that inference needs to be tested whether it is logically consistent. Now, this logical consistency is from 2 points. Okay. One type of a logical consistency, we call it as a syntactic consistency, and the other we call it as a semantic consistency. The syntactic consistency corresponds to there should be no statement that could be generated in the logical system that we are testing, which says P and not P. That means the a statement is true as well as statement is false. If this is the case, we call that a logical inconsistency has been generated. And who has generated that logical inconsistency? Obviously, the new action added. Because if there were no new actions or no new devices, there were no logical consistencies because it was the whole pool, knowledge pool was validated for being what we call it as consistent. So that is what we call as a syntactic consistency. It is for essentially one statement, not necessarily only the inference which is drawn. Also, it could be for something different than the inference which is drawn. The semantic consistency corresponds to whether the inference which is drawn by the model which is created by using a new action, whether that inference creates trouble as a whole in the knowledge pool. That means whether it percolates problems of non-consistency, creating non-consistency in the existing set of what we call it as the pool of truths. Uh, I will give you example here, simple example here, which all of us are aware of, is for something Euclid's geometry was the first one which had been very rigorously constructed in this formal fashion. And there was something which is called as a fifth postulate, which was under consideration. And that fifth postulate was that from a point which is not a part of a line, only one and only one line can be drawn parallel to a given line. Okay, this was the fifth postulate. Now, uh, this fifth postulate was consistent. It was seen that this fifth postulate is consistent, okay, when we are talking about geometry, which is in a Euclidean space. Euclidean space means flat space, okay, essentially flat space, okay, or a right angle space. Now, two mathematicians had proposed that a different kind of fifth postulate can also be looked into. Uh, One of them was Gauss, of course, and what he had said that from a given point for a given line, not only one, but we can draw many parallel lines, not only single one. Okay, and then we end up into something which is called as a Gaussian geometry, which is a spherical geometry, and so on and so forth. Uh, and there was correspondingly also a hyperbolic geometry, which is or Lobachevsky geometry, which is where the fifth postulate was said that for a line and a point, from the point we can draw infinite number of lines. Sorry, uh, which could be parallel to the given line, and it was shown that only one, none, and many or infinite. Okay, all of the three possibilities are consistent with the rest of the geometry. Geometry can be constructed or extended in a consistent manner, assuming any one of this particular postulate, only any one variant of this what fifth postulate. So that's what we mean by testing a new axiom or testing a new hypothesis of an axiom and see whether it creates troubles of the kind syntactic non-consistency or semantic non-consistency. Similarly, what we have on the real world side or physical side is that whatever is the inference drawn, we have to check it with reality correlation. For example, one of the simplest thing that we can look at, okay, is extension of gravitation theory by Einstein in terms of general relativity, okay, and then finding out whether the inferences drawn from the modified model by adding new premises, okay, in the physical system, whether they give rise to inferences which correspond to reality or do not correspond to reality. So this can be checked. Reality correlation can be checked by using an experimental setup, or it can be an empirical setup also. In some cases, for example, when we are in the domain of soft sciences, hard experiments are not possible, but empirication is possible. Hard experiment means that we will get the same result at any time, anywhere, and irrespective of the person who performs the experiment. That's why we call it as a PTP, place, time, and person independence. In case of empirical validation or correlation checking, okay, there might be some differences. We have to make some leeways in this strict adherence. But statistically speaking, the inferences are valid. Now, this kind of a empirical correlation is what is required in what we call it as the uh, drug, so to say, qualification or drug acceptance. Okay, whether the drug really, whether it does cure or it's only a placebo effect. So it is an empirical correlation. But anyway, whatever are the inferences drawn, they are to be correlated against the reality. And it can be done either by using experiments in hard sciences and empirication in soft sciences. Soft sciences being typically psychology and sociology. So this is what happens when we have added new axioms or new premises. okay, we get new inferences, and these new inferences then give rise to new inferences are actually the new effects or our extension of our understanding of the world in terms of truths and facts. I have not included morals and norms in this model, but they can be treated in a very similar fashion. Okay, but morals and norms normally will fall into empirical kind of a category, or but the treatment will be roughly similar. Now, if the if we have the validated inferences, that inference is now available to what we call it as for building products or building services or building advices. Okay, so if it is a psychology, probably advice will come into picture. Okay, if it is a product, I mean, if it is a hard science, okay, a product can be built out of it. For example, navigation. If the gravitation theory is correct, then the corrections which are done by the satellite to find out where the vehicle is and its navigation, okay, it can be used reliably by the mankind as a product. So validated inferences will end up in giving us services, products, or advices, as the case may be. Under these circumstances, okay, we accept the new actions or new premises. This then becomes a new shift or new paradigm, and we call them as axiom revisions. We do an axiom revisions and we include them in the already known axiom pool, okay, knowledge pool of axioms. And if it is as far as the axioms are concerned, similar thing we do, that knowledge bootstrapping is done by adding premises, revisions of the premises into what we call it as knowledge pool of axioms and premises. And the validation cycle, okay, if the inferences are valid, this will end. This is what happens, and the knowledge pool of the mankind increases. Now, suppose it happens, it can as well happen that the inferences which are drawn, whether it is a formal truth inference, can end up into fallacy. Okay, and this fallacy is a troublesome. It is either not syntactically consistent or semantically consistent. Then we end up something into something which we call it as fallacies, and these fallacies then demand that the new action which we had added to build a new model to extend our knowledge have to be given up. Okay. Same thing can happen on the semantic side or the empirical side. If the inference is wrong, there will be no reality correlation, and we will have something which we call it as discrepancies. So, two things will happen. If new actions and new premises are added, we can build newer and newer models to extend the scope of the knowledge pool which we have got. This will end up into either the validated inferences, which will give us the possibility of using them for products, services, and advices, or it might happen that they the inferences may be not consistent or correlating to reality, and we will have fallacies and discrepancies, and these particular new actions and new premises need to be discarded. This is a typical cycle both for formal validation of formal truths or mathematical truths, and formal correlation, formal validation of premises or what we call it as facts. So this is one of the used models of what we call it as scientific method. This is what we call essentially a scientific method. Now, I will continue, and I have answered the question what is scientific method, and now I will come to the question, does science generate new knowledge? So let's see whether it generates and how it generates. So we have to then to go to this particular mechanism. Okay, validated and newly added truths and facts or premises and axioms. Okay, validated and newly added truths and facts create gaps in the existing knowledge pool. That means what happens is the new premises added or actions added, okay, they are validated, they are valid, they are not creating any kind of inconsistency or non-correlation. However, there they can create something which is called as gaps in the existing knowledge. So this is one source, okay, which is giving us an opportunity. The other opportunities which are provided by the validation cycle is the fallacies that occur and the discrepancies that occur on the empirical side and the fallacies which occur on the formal side. The fallacies, the gaps, and the discrepancies trigger the agent's creativity. Actually, all knowledge is extended by agents, and it is not necessarily now has to be only a human agent. It can as well be a synthetic agent. Okay, and these form the triggers to the synthetic agents and their creativity. Now, what exactly is a creativity? From these gaps, fallacies, and discrepancies, okay, uh, uh, I will shift the language here, and it will depend on the pratibha of the agent or human or a conscious human. It will be the imagination or the insight, which can be clubbed under pratibha. It could be induction and abduction, which can be clubbed under what we call it as anumana. Or induction correspond to, say, for example, for a Goldbach conjecture. Say, for example, for a Goldbach conjecture, we test it for the even number 4, we test it for 6, we test it for 8, and every time we find out that it is a sum of two prime numbers. It can really be represented by sum of two prime numbers. And we test it for, okay, 100,000 even numbers, and still it holds. It is still not proven, but it is indicating something, and by induction we can say that probably this is known as a Goldbach conjecture, and that's why it is called as a conjecture. Probably this statement that every even number can be represented by two odd primes is indeed a truth. Okay, it has not yet been proven that it is a truth because there is no formal truth yet. It is still a hypothesis, and that's why normally it is called as a conjecture. But this is an induction that 4 can be represented, 8 can be represented, 12 can be represented. So from that we can induct that every even number can be represented as sum of two primes or odd primes to be precise. That is what we call it as anumana or induction. Another mechanism to get to something which is new, not considered, okay, in something which is called as a contemporary knowledge, we can get to something by a mechanism called as abduction or abductive reasoning. And abductive reasoning is nothing but from a given result finding out the most probable causes. And since we are finding out the most probable causes, okay, probably one of the cause, okay, could be a good candidate to be added as a premise or as an action. So induction and abduction are two mechanisms, okay, which can give rise to new hypotheses. Imagination and insight, for example, okay, these are purely what we call it as the abilities, okay, intuitive abilities of an agent. Apart from these four mechanisms, there are two other mechanisms, okay, and which are very routinely used. One is known as symmetry, and other is known as analogy. That means what happens is you have a situation, you know something, Okay, and then you look at something which we call it as, is there anything analogous that we can also test? Okay, such a analogous situations exist in engineering and physics. They are abundant. For example, the frequency at which a LC oscillator works and the oscillations created by a mass and spring system probably will give rise to same equation or isomorphous equation. This, when this is the case, we call that is that the two systems are analogous. Okay. So that means we have done something for a system. Then you look for an analogous system and check whether the same equation is going to work for that system also. Okay, so that forms a candidate. Okay, candidate hypothesis. The other mechanism is symmetry, and this is a very powerful mechanism. Symmetry is a very powerful mechanism. For example, this symmetry has been used by Einstein, okay, and to something which we call it as getting to special theory of relativity. Okay, that means that symmetry was an extension of a symmetry called as a space symmetry and a time symmetry or energy conservation and momentum conservation. Okay, but now that symmetry has to be that for two systems which are moving with a constant velocity, different but constant velocities, will have physical laws identical. So that is a symmetry. So special theory of relativity was essentially found out by using a tool called as symmetry, and that was quite. Symmetry as a tool has been used many number of times. So these are some of the tools, techniques, and intuitions that are used, okay, which are triggered by fallacies, gaps, and discrepancies. What do? They actually do generate new probable hypotheses. And these are the candidate hypothesis. And in the last or previous slide, which we have seen new actions and new premises. Okay, these give rise to something which we call it as new actions and new premises, and then we push them through the validation cycle. Okay, and the whole thing repeats again and again and again. And mankind has used this mechanism, okay, of leveraging, bootstrapping the knowledge pool in terms of truth, facts, morals, and norms by using essentially the same mechanism. And every time a cycle takes place, okay, we have learned, we means the mankind has learned something new. And this is the reason, okay, why we have made progress. And this is also the reason why human species has succeeded. At this particular point, I will like to take a break.